And welcome back. Now today we're going to talk about that item I mentioned in my blog last week, and sorry, you missed it. Well, there's the blog address on the screen right now, because we're going to be talking about this Maine's Opto Coupler Isolation Board. And I'm going to have to watch where I put my fingers on here, because some of this is at Maine's potential. Well, not at this very instant, obviously, because I haven't connected it up yet. If I zoom back a little bit, wrong way. So if I zoom back and turn the camera a little bit, right, you can see there that I have this safety thing here, so only when this lid goes down is Maine's going to be applied, and I've got 5 volts coming at this end. So what is this Maine's Opto Coupler thingy? Well, as I explained a little bit in my blog, what it allows you to do is have Maine's come in on one of 3 ports here. I'm trying not to move it too much because it is actually blue tacked to the back here. Let me just move it in a little bit though. So, there we are, that's better, isn't it? Right, so it's not connected now, so that's fine. Okay, so what it allows you to do is put Maine's onto one of these 3 inputs and the neutral at the bottom, and then basically keep your hands well clear. See this white outline on the board here? That means everything in here is at Maine's potential. And even worse than that, there are some little tiny bridge rectifiers in here. Let me have a look. I think so these here, these little things are bridge rectifiers to provide a small amount of DC. Now admittedly the current is tiny, but it's probably more than enough to kill you. And if it doesn't kill you, DC at that voltage, you don't want to go there. So basically, if you're going to use this board, be sensible about it, don't take risks. It could easily kill you. Think about where you might use this in a project and then steer clear of it when it's switched on. Okay, now I'm going to use this, more than likely, in my home automation project. But this could be used for anything, an Arduino, Raspberry Pi, any microcontroller that needs to have a signal when there's a main signal present. And this basically keeps your, whatever you've plugged it into, microcontroller probably, safe. So the mains comes in, goes through one of these big fat resistors to bring the current right down, is rectified by that chip at the top and smoothed a little bit with the capacitor and all that, and it turns on this little green LED. From the other side, totally isolated, because you've got these 3 opto isolators in the middle. And if you need a bigger explanation of what an opto isolator is, you need to look at my relay video from quite a while ago. There, that's the one on the screen now. It explains it in quite good detail. I'll go into it a little bit more in a minute. So this side knows nothing about what's happening over here. All these transistors know is that they're being turned on or not, depending on the voltage applied to them. But at least the mains is being kept very separate. Now you might argue, why on earth are you dealing with mains, Ralph? What is it you could possibly want for a mains control? Well, very simply, I want to know in my workshop, have I left the lights on? Is the heater on right this very minute? Never mind what the Raspberry Pi or Arduino or whatever is telling me. I want to know for sure, is it on or not? Have I inadvertently left it on? Has the microcontroller or computer that I'm running all this with, has it crashed? And they do. And therefore the heater, for example, might be left on all night. I don't want that. So I want a mechanism whereby I can detect actual mains from 3 devices and plug those into a device of my choice, and that will tell me potentially, well, within the workshop, maybe not, it's not as useful, but on my phone, for example, okay, it'd be very, very easy to write an app to say, what's the state of these 3 outputs? And we've done a little bit of that in some of the videos going back, but this will be expanded on in quite some more detail going forward over the next few months. So let's have a quick demo of what I'm doing here, hopefully without killing myself, because otherwise it'd be a very short video. So what I've got here is mains connected up here, hence the light in that little thing there. So when I shut this, what it's going to do is apply mains to the very first input here, which I'd expect then that green light to go on, that red light to go on, and this pin here, well, something will happen to it, and we'll see what that is. I've got my multimeter here. Is that visible? Yes, that's all visible. Now I've got to remember, now you saw that there, this moved, my immediate reaction was just to straighten it up a bit. I mustn't do that when the mains is on, because I'll go and straighten this up and go and have an accident, so we don't want that. So I'm going to try not to move it too much. Right, let's close this down. there we are, on. Now what you can see immediately is that the green light's gone on at the top, because that's the mains to the first channel, and this red light here on this isolated part has also gone on. So it means I can detect something now on that pin. Well, let's put my multimeter on that and just see what it is I am detecting. So ground is that pin there, and the first pin there is, as you can see on my multimeter, just about, you can see that says 0. Interesting, isn't it? Caught me out. If I go to another pin we haven't got mains connections to, it says 3.55, and the third one also says, well, 3.56 in this case, but it's close enough, isn't it? So what this does then is obviously drive the pin low when there's power applied to it, which in some ways is a more robust mechanism for detecting, well, a signal. If you're going to detect a signal with voltage, and this device can take between 3 and 5 volts in here, so it's TTL compatible really, it's still easier for your microcontroller to detect the total absence of voltage than a somewhat indeterminate voltage. Is it 3.3? Is it 5? Well, they've made it easy for you here to say if it's not 0, then it's definitely going to be a voltage being applied. Now, just to prove that the other channels work as well, and they do the people I bought this from, what they call Moore Estate, that's Russ Moore who runs that, I'll show you that in a minute. They do a single channel version of this as well, but in the meantime, let me just take this out. I've got to be a little bit careful with it. So power's on, the first one is lit, and indeed the red one as well. Where's my little chopstick? There we are. So that's on and that's on. So if I take that out of there, see it goes off, and I apply it to the second one. Ooh, not a great connection. That one goes on, and that one as well, and the last one as well. So it's all pretty obvious, isn't it, about how it all works. Now, no, I'm sorry, I'm going to have to disconnect the power again. I'm just too nervous about all this. Going to kill me. Right, there we are. I've survived. Right. So this is going to be connected into some sort of control unit. I mean, it's probably, in my case, going to be connected to a Raspberry Pi, because that's the way my workshop automation seems to be heading. But it could be connected to any bit of electronics, to be quite honest. It doesn't even have to be a microcontroller. You could connect the output of this to, well, just a transistor and a light. Who knows? But I'm going to connect this into my lighting, my heating, and something else I haven't quite thought of yet, but it just sounded like a good idea to get a 3-channel one, because a bit like sockets on your workbench, you can never have too many. So that's what it looks like. Now it does say high voltage everywhere on it, as you can see, and all these little warning things, and underneath I think it says something as well. Oh, there's my blue tack. Yes, it says high voltage as well. So everything on this side basically you need to steer well clear of, and I really want to emphasize that, because I can't afford to lose any viewers really, so it's a selfish desire on my part, so you don't go and kill yourself. Right, so that's that. Let me just show you where I got it from. So that would be now I did buy this in the UK, and as I told Russ, normally I buy stuff from China or somewhere, because of the price differential really. I couldn't afford to buy everything in this country. But he says, yeah, but then it takes forever to get you. And yes, it does. It can do. Hello, I've gone off screen. Doesn't like me. I've ordered stuff from China, and I've had it within, I don't know, 10 days, maybe just over the week. And sometimes I've had it from the Far East, not necessarily China, but somewhere around there, and it's taken like 2 months. And that's so long that even the seller has given up and said, all right, I'll send you another one or refund you or something. And sometimes the original then turns up, or it never does. So it makes you wonder, doesn't it? Anyway, Russ sent it to me, and now I was a bit cheeky on this, as you can see on here. At the moment it's $12.30. I can't remember what the price was when I ordered it, but I wanted it quickly to play about with. I gave him a cheeky offer of 10 quid, and I said, look, I'm doing an Arduino channel. I'll promote your site, or at least tell people where I got it from, and they can decide whether they're going to buy it from you or not. 10 quid, a little bit of a discount, and he says, yeah, go for it. So here we are. So that's Moore's Estate. It's a UK site done by Russ. Now he does say somewhere down here, let's have a look. So here's the little bit of detail about it, not very much. Yeah, it says you can use this between 3 and 5 volts, and as I say down the bottom in this bit, and I've got it set to 5 volts on my power supply at the moment, no more, because I'm looking at, well, I don't know what I'm looking at plug it in yet, but if it's a Pi, then it's got to be a 3.3 volt input, no more. I've tested it with that, works as well, so that's okay. And you can also put it into PLC input, which is what? Programmable Logic something Controller. Programmable Logic Controller. Okay, not sure quite what that refers to. Maybe it doesn't mean a microcontroller, I don't know. Anyway, now it says, look, for one channel version, please click here. So let's do that and just see what we come up with. How much is a single one? Oh, that's not too bad actually. £5.26 for a single version. So basically it's just a third of one of these. So if you only got one thing to detect, and that was my initial intention, just to have one for the heater. I thought, well, I might as well do it for the lights and have a spare, if you like. Admittedly, you can get these much cheaper in the Far East, but then, well, whether you like, or whether you can even order from the Far East, depending on where you are. So there we are. That's Ross's More Estates website. Jolly good stuff. He does loads of other stuff as well. And I think that's where the plugging of his site stops. But you can have a good look. And thanks, Russ, for giving me that little discount. And it will, this one certainly will be in my my workshop automation project, without a shadow of a doubt. Good. Now that was fairly simple, wasn't it? I mean, you know, main's in, output goes to 0. I mean, there's not a lot to it really, and that's what I like. Simple. The Opto Isolator circuit in the middle, if you're wondering how that works, let me just draw that up in a 30-second summary just so that you understand what's going on here. So let me talk to you about Opto Isolation and exactly what that means in terms of, you know, protection for your device. In fact, I'm going to take myself off this picture. Right, now I can draw without you seeing the top of my head. So basically, in that particular device, we're saying there's a mains input, well, mains reduced down and rectified. So on this side, yeah, we'll have a line and a neutral. But what this does is, okay, you have a big fat resistor. Let me just have a look what value resistor they're using. Right, so he's using actually on that board 150k. Right, it's then going into some sort of bridge rectifier. So let's just use a single die just to prove the point, right? So it's being rectified here. So you've got DC at this point, although here it would actually be half wave, it's full wave, and then there's some sort of capacitor just to smooth it out, and that's probably about it. So what happens at this point is that this here is fed into the Opto Isolator, which is no more than a diode. And this diode would expect, I don't know, 1 volt, 2 volt, 3 volts, whatever it is they've built into the Opto Isolator, which I can draw to assist in our understanding in a nice dotted green. There we are, look. So this is the Opto Isolator, a chip that protects our device. So that's some kind of, might be infrared, might be visible light, but you wouldn't know one way or the other because it's inside a sealed device. So that goes in there and back out again. That probably then just goes to the other side. So that's pretty much what happens one side. And as you can see from our point of view, all it does is light up a little LED, even though you don't get to see this LED, which is why we need another one the other side, if you remember that green one that went on. So okay, so what happens on this side then? Well, this is even simpler, to be quite honest. On here, you've got a photosensitive transistor. No, nothing special about that. So it looks probably something like that. It doesn't actually have a base. So it's photosensitive, and if light falls on this, current flows here. This is probably going to be connected to 5 volts. Might be a little bit lower, might be 3. Let's say 3 to 5 volts, that side. This side, of course, will go to ground. Now, in order to stop a short circuit, if this was to conduct now, it would conduct the 3 to 5 volts to ground and probably burn itself out. So what you've probably got in here then is a resistor of some kind. Now, the resistor here might be as large as 10k, maybe. maybe, and that then is the out. So that's the VCC. So the output here, if this isn't conducting, so effectively that is not present in the circuit if it's not conducting, then the output here would be at VCC, right? Now I'm not saying it will be 3 to 5 volts, it might have some kind of regulator on board or something, but basically like that. Now as soon as this conducts, it effectively puts this 10k to ground, doesn't it? So that then does go to 0, which is effectively the effect that we saw on that. When this thing was turned on, the output went to 0, and when the output wasn't on, it went high to 3 point something volts, isn't it? So that effectively is what opto isolation is. We're dealing at the sort of micro controller side, if you like, with this bit here, all nice and safe. And you can see there's absolutely no connection, no electrical connection between this side and this side. So no matter what happens here, it's not going to affect here at all, which is what you want. You don't want something like a resistor or a choke or anything that allows mains to directly connect to your microcontroller or computer. It just isn't worth it. Hence the opto isolation. Brilliant, job done. So before I pack everything away, let me just draw your attention to this wire which I bought a while ago now. It's not two core, well I suppose it is 2 core but multi-stranded, red and black, and as you can see on this one I've actually tinned the wire so I could put it into this thing, and I've tinned the other end as well. You're not supposed to tin stuff that goes into mains, by the way. Never ever solder stuff that goes into like plugs or consumer units. Why? Well, because copper itself is soft enough. If you've ever wired up a consumer unit or indeed a plug, you do it tight. If you go back an hour later, you'll find it's not tight anymore because the copper in the wire has squished down. Now solder, as you might imagine, is a lot softer even than copper, so you do it up what you think is tight and it won't be, and it can cause, quite frankly, a few problems, because you know the copper and the solder then get squished under pressure and they actually become loose. You could actually pull them out after a while. So never solder mains wire. That is wire that carries mains voltage. But for the little things like this I do. The only time I would say you can solder mains voltage is if you've got stranded wire that you want to put into a mains plug. I sometimes solder the very, very tip just to keep all the strands together so they don't all splay out as you're trying to put it into the hole or something. But that's all I do, if that. Not very often, but occasionally I do. Now this wire, as you can see, tinned very nicely. Now I have 25 meters of red and black wire, to all intents and purposes identical to this, and which I'm about to throw out. And you'll go, what? Well, here's a bit of it that I tried to tin earlier. So here it is, look. It looks the same. Let me just get the end. So here we are, look. In fact, it feels a little bit thicker. Well, it is a bit thicker. Look, it's the bottom one that's the rubbish one, as far as I'm concerned. Because try as I might, I could not tin that wire at all. It's all gone a bit funny and it almost looks corroded at this point. And I've had trouble with this wire ever since I bought it. And I thought, now which one was it? I could never remember which one it was. So now I've identified it. This wire, all 25 meters of it, is going to get chucked because I just can't afford to have wire like this that I can't solder going forward because I need it in various projects and things. So it's a pity. If anybody's quick, you can have all that wire that can't be soldered. I'll just send it to you if you like, but first come, first served. So anyway, that's going in the bin as of well, middle of next week, really. So first come, first served, as I say, if you want it. This is the one I'm keeping though, and I don't know how you can differentiate really, because I bought both lots of wire from eBay, I believe, you know, from bricks and mortar companies behind the scenes, and I don't know why that other stuff didn't solder and this one does. I mean, you'd expect all wire to solder, wouldn't you? But there we are. So just thought I'd bring that to your attention. Right, okay, let's move on. And there we have it. Pretty simple item, isn't it, really? Nice and neat, and is going to serve me, I hope, in good stead, because I do need to take these mains voltage. So just remember though that that is high voltage. That warning, well, 3 times isn't printed on there for fun. Do not touch any of this when it's actually connected. Be easy to do, but please don't do. Okay, that's it for the video. It's quite short, this one, because I've listened long and hard to what people have said in the comments. I'm trying to cut things down. No promises. This one might be short, but the next one won't be. Also, thank you very much to those people who responded to my blog entry about automation on hold for a bit. This is now May 2018. If you want to know what happened, that's fine. You can read that blog, but thanks very much. You know who you are, who commented. Thank you very much for your comments, and we'll move forward on that one. The other thing I have is a new microphone pop filter, because somebody mentioned that and I did notice it. I think it's because in the workshop it's in a slightly different place to where it was before. Before it used to come directly in front of me there, out of between my screens and down. Now it's at the side, and in fact if I move my camera right up, you'll see there it is. Look, see, and I've got this rather nice pop filter on here, so it's not too big. So hopefully the quality of sound in this one is going to be better than what it was in the last one. Well, you can let me know. In fact, I'm sure you will. Okay, that's it. So that's it for now. Next time, I want to talk a little bit more about analog inputs, but not for the Arduino. There's a cliffhanger. Well, you know what I mean. Thanks for watching. See you in the next video, and look at that blog. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.